If you want to learn more about optical transport concepts and Juniper Network's optical transport offerings, be sure to check out the Complete Optical Transport Primer e-learning series on Juniper Education's Learning Portal and Juniper Network's instructor-led Packet Optical Transport Workshop Open Line Systems. And now, to the Learning Byte. Hello and welcome to this Learning Byte. Our topic is creating network topology on Juniper's proNX Optical Director, or POD. My name is Meir Petler, and I am with the Education Services Department at Juniper Networks. Let's get started. After successfully completing this Learning Byte, you will be able to describe the process of defining the topology of the intrasite and intersite optical fibers within a network in the proNX Optical Director. And you'll be able to explain how a user can track the progress and verify the success of the topology definition process by using the pod administration log and the monitor screen. We will be showing the features of the proNX Optical Director, or POD, using an optical network deployment example that we have in one of our labs. This is a drawing of the network we will be working with. As you can see, the network has 3 sites, where each site has a ROADM node within it, and those 3 nodes are configured as a ROADM ring between the 3 sites. The ROADM ring in our network is not yet configured. The node 2 site is the site we will focus on in this example. It is equipped with 2 TCX 1000 RDM20 20-degree ROADM devices that are connected as a 2-degree ROADM node. 1 degree, the .211 device, is looking west, and the other degree, the .212 device, is looking east. These 2 ROADM elements are interconnected via one of the UX ports in each element using a fiber pair. These devices are set to use the standard 96 wavelength grid using a 50 GHz channel plan. We will start our discussion by logging into the proNX Optical Director. We get to the first screen, which is the dashboard screen, and we can go and look at the devices that we currently have in the system. We have 3 sites, and each site contains 2 ROADM blades. And what we are going to do right now is perform the connection in one of these sites, the site Boston Site 2. We are going to connect U0 port of emulator 211 to the U0 port of emulator 212. When we want to implement topology, we need to do that under the Network tab. Going into the Network tab, we can see that the side menu provides us with the ability to configure optical transport services or to configure device links. We are going to configure a new link between the 2 ports that I just mentioned. The link configuration screen provides us with the ability to define the source. In our case, our source is in site 2. Our device is the emulator looking west, and we are going to connect port U0 of that device to, under the same site, our other ROADM blade, ROADM 11, port U0 of the other device. You will notice that the fiber type mentioned here says not applicable because the pod understands that it is a connection within the site, so there's no need to put in calculations regarding that fiber attenuation and behavior. We are going to hit create, and going to the administration screen, we can actually see that the device edit command has been executed successfully. Going back into the network screen and looking at the current topology, we can see here that the connection in Boston Site 2 between those two elements is currently up and in service. What we are going to do now is we are going to create the links between Boston and the other two sites. So we are going to go back to the create link screen and we will connect Boston site 2. We are going to choose our west ROADM. We are going to select the line port of this ROADM and we are going to ask to connect that line port to Ottawa, the west ROADM in Ottawa, and you see that it automatically told us that the only port that we can use here is actually the line port. You can also see now that I have the ability to select what type of fiber is used for the RAN that connects those two sites. And we are choosing the single mode fiber. Let's create this link and let's create another link, this time connecting Boston east-looking ROADM line port to New York, the west-looking ROADM, and again line port using single mode fiber. Going to the administration screen, we see that those provisioning commands have been committed successfully. We can now go back to the Networks tab, and under Device Links Current, we can see the list of all the existing links right now on our system, including the new links that we have just created, both the intra-site link and the inter-site links. We can also see our links now on the monitor screen. We can see that our three sites are now connected. We can see the links that we have created between Ottawa and Boston and New York. What we also see is that those links are currently marked in red or down. If we click on a link, we can see the state is in service, but the operational state is down. The reason for that is no services are currently defined that are using this link. Therefore, there is no light on those links. Therefore, the ports are considered down. If we look on the other link, the direct link between Ottawa and New York, we can see that that link is active. Reason being, there is already a transport service defined between those two sites using this link, so it is lighted up. The ports are measuring energy, and we can see that those ports are up. Let's recap. In this learning byte, we described the process of defining the topology of the intrasite and intersite optical fibers within the network that the proNX Optical Director is controlling, and we explained how the user can track the progress and verify the success of the topology definition using the pod administration log and the monitor screen. This concludes this learning byte. Thank you very much for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.